Minimum embedment depth comes from a variety of conditions. Embedding below the frost line to avoid frost heave, enabling the removal of the topsoil organic layer, avoiding erosion and scour from water and wind, realizing the full bearing capacity of the soil, and garnering extra capacity from passive pressure or skin friction, also known as sidewall friction. So regarding extra capacity, for example, ramp wall and extra access ramp embedment should be minimized to reduce excavation while maintaining full bearing capacity to reduce the risk of settlement. However, while the same trade-off occurs with anchor embedment, a shallow anchor will reduce the ability of the anchor to act as a shear key, which is not considered, but as well as it will reduce skin friction or sidewall friction capacity of the anchor. Remember, we ignore the top 30 centimeters of soil for sidewall friction. For the foundation, we're most concerned about realizing full bearing capacity while minimizing the amount of excavation. So, our first stop in this lecture is the IBC, International Building Code. Section 1809.4 cites that the minimum depth of a shallow foundation should be no less than 12 inches or 30 centimeters below the undisturbed ground. This should be altered based on frost depth based on section 1809.5. But for now, we will consider this negligible, with reasoning discussed in another lecture on cold weather conditions. There's no specific information for masonry walls and gravity anchor beams, but we can extrapolate this from the foundation requirement to set a minimum, not necessarily recommended, but a minimum embedment depth of 30 centimeters for anchors, ramp walls, and extra access ramps. So I've drawn a little diagram here for you. The minimum is to realize full bearing capacity of the soil and minimize any differential sediment that will lead to cracking and loss of capacity. Now regarding foundations, bearing capacity and therefore any differential sediment is much more of a concern, especially in three-tier abutments. There's also more exposure to any scour from water runoff and wind. So further research beyond the 30 centimeter IBC minimum would suggest that high plasticity clay soils need further embedment up to 100 centimeters or 1 meter, and this would be our worst case scenario type of soil. But then for a sanity check, we can use the Rankine formula to calculate the minimum shallow foundation depth for typical EIA soil. And this can be redone for site-specific conditions if we have that sort of information. So here's the Rankine formula. And if we plug in the numbers for P, our bearing capacity, gamma S, our soil density, and phi, our internal friction angle of 30 degrees, and rearrange the units slightly to make this work, we get a DF value of 0.9 meters. And so we can comfortably set our foundation minimum at 100 centimeters or 1 meter.